So in this section, we'll just look at more differential equations, and there'll just be, some of them will be more difficult than what we've been doing, but everything we've been doing has been separable because we can separate the x and the y, and that's the only type of differential equation that we'll have to solve. Alright, let's review here. We can separate the x and the y. So we have x squared plus 2 multiplied by dx, and let's also multiply both sides by 3y squared. So we separated x and y, then we integrate, so that's going to be 3y cubed over 3, and here we have x cubed over 3 plus 2x, and we can just say that y cubed is x cubed over 3 plus 2x plus c, and that is a general solution. Alright, pause the video and try that one. So rewrite y prime with dy dx, and let's separate the variables. We'll divide by y, multiply by dx, and divide by x. Integrate. So that's 1 over y dy. The antiderivative of 1 over y is natural log of y. Natural log of x. Exponentiate both sides. Let's write that as e to the ln absolute value of x times e to the c. And we'll call that C1. So we just have this product. This is going to be, it could be rewritten as c, and then e to the natural log of x, absolute value of x is just absolute value of x. So we have c and then y. Without the absolute value, you can put positive or negative, but c can be positive or negative anyway, so I don't see why you need that, but sometimes they write it. Alright, try that one. Pause the video. Let's rewrite y prime as dy dx. And we have x is on the right and the y is on the left. So all we have to do is move the dx. We have the y dy on the left, y dy, 6 cosine pi x dx. And that one's an easy one. Here we would need substitution. If we have u equals pi x, du is pi dx, du over pi is dx. So on the left we have y squared over 2. Here we have cosine u du over pi cosine is the derivative of sine, so we have 6 sine u, and put the pi over there, plus c y squared over 2, and we'll substitute back what u equals, and we can also multiply both sides by 2. So that's 12 over pi sine pi x. And instead of writing 2c, we can just call this c1, so that when we multiply by 2, 2c1 is the same as, or just called c. This equals 3e to the x. Okay, pause the video and try that one. Rewrite y prime as dy dx, and let's separate the variables. 4y is going to stay, and we just need to move the dx. 4y dy, 3e to the x dx, integrate 4y squared over 2. This will be 3e to the x plus c. So that reduces to 2. And divide everything by 2. C over 2, instead of writing c over 2, we can just say it's c1 over 2, which is just some other number, c. Alright, so here we have a differential equation and an initial condition, so we'll be able to solve for c. Let's write this as x to the 1/2, y to the 1/2, dy dx. And we need to separate the variables. Subtract x to the 1/2, multiplied by dx, so we have y to the 1/2 dy equals, we integrate, add 1, so we have 3 over 2 over 3/2, and here we're going to have adding 1 there, same thing, 3 over 2 over 3/2, plus c1. Let's rewrite that as 2/3. And here we can have negative 2/3 x to the 3/2 plus c1. Multiply both sides by 3 over 2. So we'll have y to the 3/2. This will cancel that. We have negative x to the 3/2. And then 3/2 c1 is just going to be some other constant c. Now we substitute. The initial condition is x1. X is 1, y is 4. So at 1, 4, we'll have 4 to the 3/2, 1 to the 3/2 plus c. This is the square root of 4 is 2. 2 cubed is 8. And here we have 1 is just going to be 1. So adding 1 to both sides, we have 9. And we get y equals y to the 3 halves equals negative x to the 3 halves plus 9. We could write it with y equals, now we have a cubed root and we're going to cube root and square. So cubed root, just copy that and then square it. Okay, pause the video and try that one. Rewrite the y prime as dy dx. We also can move the 2 out in front. That's not calculus, that's just a property of logarithms, and allow us to do have an easier integral. At this point we want to separate x and y, so let's move that over. So I added ln x squared and then also moved the 2 out in front. And we want to multiply by dx and divide by 2x. So dividing by 2x, multiplying by dx, we can cancel those, and now we have dy equals ln x over x dx. We're going to integrate. Let's let u equal 1 over x. No, u equals ln x. U equals this because du is 1 over x dx, and that's going to make that work out. U is ln x, so that's u. Dx is x du. The x's cancel. And we have y equals ln x squared over 2. That's the general solution. And then we need to solve for c using the initial condition 1, 2. So at 1, 2, we have 2 equals ln 1. ln 1 is 0. 0 over 2 is 0. C is 2. And the particular solution is ln x squared over 2 plus 2. And let's just do one more. All right. Well, that'll be a challenge, but might as well try that on your own. So pause the video and try that. So we want to focus on y prime, and that has to be dy dx. We want to get the x's together and the y's together. So what if we write it as y prime equals x radical 1 minus y squared. I'm going to move that over and then divide by that. Then let's just rearrange this so we have x over radical 1 minus x squared, and then we'll have radical 1 minus y squared over y. Since these are multiplied, we can reverse the order, and now we've grouped the y's and the x's. Let's multiply by the reciprocal of that, and we'll also multiply by dx. So the reciprocal of that gives us this, and then we have to integrate that. But you can see if we let u equal 1 minus y squared, it's going to work out to have, we need a dy there. The substitution is going to work, so we'll say u equals 1 minus y squared. Du equals negative 2y dy. So du over negative 2y is dy. And let's just use v over here. V equals 1 minus x squared. dv equals negative 2x dx. dv over negative 2x is dx. Y over, this will be u to the 1/2. dy is du over negative 2y. X over v to the 1/2. v to the 1/2. And then dx is dv over negative 2x. And we can cancel the x and the y. So this is going to be u to the negative 1/2. We have a negative 1/2 here, so negative 2 goes out in the denominator. U to the 1/2 moves up to have a negative half. Here we're going to have negative 1/2 in front, and then v to the negative 1/2. We can cancel the negative 1/2, and now we're going to add 1 to this and divide, add 1 to that, divide. Alright, so we have, let's multiply both sides by 1/2. We can cancel the 1/2, and that'll become c. U to the 1/2 is square root of u, and u was 1 minus y squared. And here we'll have square root of v, which is 1 minus x squared, plus c. Then we can find the constant using the initial condition of 0, 1. So initial condition 0, 1. At 0, 1, we'll copy the general solution and put a 1 for y and a 0 for x. And the particular solution is that looks like we could, yeah, we're going to isolate y, square both sides, remember that we can't just square that and square that. We would have to do FOIL, we have to distribute this, and we'd still have a radical left. Let's continue by subtracting 1 and then also dividing by a negative. So this whole thing is negative. If I subtract 1 and then divide by a negative, it'll be a plus 1. Alright, and then square root. When we do the square root, we have a positive or a negative, and this comes up with particular solutions. We have to know which one to use, but it's pretty easy because the initial condition tells us which one to use. What is the y value going to be? So we look up here and it says the y value is positive. I couldn't say the y value is negative. If I have a positive y value, then we can't say it's negative. So we know to use the positive option down here, and we would say that we would write it like that with without the negative. It's positive. All right. And we'll stop there.